Uh, Hello everyone. So this is second video in the list of so many videos that are going to come to ensure that we cover this important topic, which is CompTIA Security Plus, exam preparation. So I have decided to kind of cut down this, the entire preparation time or the topic into multiple videos, so that first of all, it doesn't consume so much of my space and then loading to YouTube. And first thing, second thing, I think that if we create long videos, it somehow works against the interest. When I say works against the interest, it means like the people lose that interest. They lose the interest in going through the topic. Cool. So let's come back to the stuff that we're covering in this video. This is video 2 of CompTIA Security Plus. Again, one last time, if you just genuinely go through these videos, you go through this material, that's all you need to clear your CompTIA Security Plus exams. You do not need to do something extra. Trust me, that's all you need to do, and you will easily clear your CompTIA Security Plus exam SY701. All right, so let's talk about an important concept, which is and this concept is pretty much in use in cybersecurity space, governance, risk, and and compliance space. I'm myself working in cybersecurity, and I know how important this topic is, which is confidentiality, integrity, and availability, which we also call as CIA triad. All right, so confidentiality. What's confidentiality? It's a straightforward English. There is no science related to this. It's a straightforward English. So confidentiality basically means ensures that data is accessed only by authorized individuals. So if you have a file that needs to be opened by Tom and Dick, and Harry should not open it, then only Tom and Dick should have access to that. So that's how confidentiality works. Integrity is ensuring that the data is the way it is supposed to be, the way it is created. There is no fiddling with data. That's what integrity is. That's one definition in terms of cybersecurity. Another definition is doing the right thing when nobody is watching you. That's another thing of integrity, another definition of integrity. So ensures data remains accurate and untouched by unauthorized entities. How do we do it? Well, we'll see that in the coming lectures. Availability, so making sure that data is available, systems are available, everything that's supposed to run is available. So that's pretty much important. Then we have, this is concept number 1. So important: CIA, confidentiality, integrity, and availability. We call it as CIA triad. So please remember this. This is very helpful and important for rest of the topics that are coming our way. Non-repudiation. What's non-repudiation? In simple language, if I send you something and there is no way you can say, no, I did not receive that. So how do we make that possible? Is through a concept called non-repudiation. And how does that work? We'll talk about that one as well. So this guarantees basically that a sender of information cannot later deny having sent it, and the receiver cannot deny having received it. So it's both applicable to both the sender as well as the receiver. Sender cannot deny that I have sent it, and the receiver cannot deny that I haven't received it. And we'll talk about the PKI structure, what is private key, public key. We'll talk about it. So, and so digital certs. So that will cover us in the non-repudiation. AAA. AAA is basically, A stands for authentication, authorization, and accounting. If you're wondering, can I say first in this format, A, let's say authorization, second A, accounting, and third A, authentication? No, that's the wrong way of doing it, a wrong way of saying it. Actually, it should always be like authentication, authorization, and accounting, because this is how it works. For example, if you log into system, it authenticates you, then it authorizes you to use certain information, to access certain folders. There is role-based access, mandatory access, and so on and so forth. Basically, it authorizes you to access few of the stuff, doesn't authorize you to access some of the stuff. Then it's about accounting. So it's like, tracking user activities, ensuring they are operating within their designated permissions. So that's accounting. So authentication, verifying the identity of users, systems or identities. When I come log into my laptop, I use password, I am authenticated. I get in, I am authenticated. Authenticating people using passwords, biometric or tokens. Authenticating systems using certificates. Okay, authenticating systems. One is authenticating people like me, like you. So we use passwords, biometrics, and tokens. Systems, when systems are authenticating, they use certificates or keys. Okay. For example, Amazon.com or Amazon.uk.in, whatever, they have a digital cert. If you go to the address bar, click on the lock, you will see there is a cert. So that's basically authenticating a system. Authorization defines permissions, determining what authenticated users or systems are allowed to do, right? So now I'm authenticated. As I told you, I get into system. Now what I'm supposed to do? Am I supposed to touch everything? Maybe not. So that's what is authorization. Authorized models. So we have some of the models of authorization. Examples include role-based access control, RBAC, role-based access control. So I have certain role in cybersecurity. I have access only to the relevant folders, files, websites, and so on, and applications, and so on and so forth. Mandatory access control. So having mandatory access control. This is something I can relate easily to the federal government. It's mostly related to the federal government, wherein certain departments, certain users have this mandatory access control across systems. Since it's a matter of it's in the national interest. So that's mandatory access control. Accounting. Okay. Tracks user activities. What's accounting? It tracks user activities. What is user doing? Ensuring they are operating within their designated permissions, right? The permissions they have got, they are operating within that. You remember we had this operational security control, we had managerial security control, right? So managerial security control, they define controls, they define the compliance, regulation, security policies, and all. Operations, we day-to-day basis, we check that, we do that. And then whatever is done, so they are being tracked. So right, basically detective under the detective controls, right? So that's accounting. What's gap analysis? A process to identify difference between current security policies and desired outcome or standards. So gap analysis is nothing but where you are and where you want to reach, in simple terms. So current security practices is this, and you want to improve it and want to reach to a particular target. That's the standard, desired standard you have set. The difference between the two is called as gap. A gap analysis, what we call it as. Zero trust. The word defines. This is zero trust. You don't trust. Okay. What's further? Adaptive identity. Dynamically adjusting user system identity verification based on context. Okay. Threat scope reduction. Minimizing the attack surface. Minimizing the attack surface. What's attack surface? Attack surface is basically the space available to attackers or threat actors to exploit in simple terms. Bigger the space, larger are the possibilities of attack or threat actors finding a loophole within the system. Okay, policy driven access control. So access granted based on policies rather than static permissions. So policy driven access control. So obviously if it is policy driven, so access is granted based on policies rather than static permissions. Okay, so it's based access policy driven controls. Policy administrator manages and updates access policies. So who is policy administrator? He is someone who manages and updates access policies. Who gets to access, who doesn't get. For example, you visit a facility, so there would be administrators. They will decide who is supposed to get in, who is not supposed to get in, right? So they are called as policy administrators. As an example, policy engine processes and evaluates access requests against set policies, right? So that's policy engine. So they processes. These people processes and evaluates access requests against set policies. Data plan. Implicit trust zones, areas where trust is assumed by default. So what is implicit trust zone? So areas where trust is assumed by default. Okay. Subject system. Entities requesting or being granted access. Policy enforcement point, where access decisions are executed based on policies. So this is about zero trust. So we spoke about the CIA, confidentiality, integrity and availability. Then we talk about the non-repudiation. What's it? Like sender receiver can't deny receiving the information. Then we talk about authentication, authorization and accounting. What's authentication, authorization and accounting? Then what's gap analysis? Fifth one, fifth one is trust, zero trust. What is zero trust? Basically, these are the things which are covered under zero trust, like having no trust at all. So, and that's why this adaptive identity, dynamically adjusting user system identity verification based on context. So when you exactly need is when it is given. Threat scope reduction, minimizing the attack surface. This is part and parcel of zero trust. Then policy driven access control, give access only based on the policy, not on the static permissions. Whatever policy says, today you have access, tomorrow you might not have access. It all defined by the policy. Then policy administrator, the people who manage the policy access control, right, or access policies. Then policy engine process and evaluates access requests against the set policies. So this is to ensure that zero trust is implemented. Then data plan, implicit trust zones, areas where trust is assumed by default. Okay, subject system. All right. So entities requesting or being granted access. Okay, subject or system. Subject means here a person, and system means kind of a system application. So requesting for granting access. Policy enforcement point, where access decisions are executed based on policy enforcement point, where access decisions are executed based on policy. So if policy says that you should be accessing SharePoint, is when you will get access to SharePoint. Policy says that you should not be accessing a particular site, you will be denying access, you will be denied accessing that particular site. Policy says that you should not be using the developer's laptop, you will not be given the developer's laptop. Okay, so lot of stuff is basically covered. Then we talk about physical security. We have spoken about it. Bollards, I have already spoken about in the last video. Bollards are those iron or the steel pillars you see that in front of the gates and all, so that some external vehicle does not abruptly get inside the physical facility. So short posters to prevent vehicle intrusion, basically. Access control vestibule, secure entry space, often with two sets of doors to control access. So you might have seen, if you go to the corporates or the big companies, you will see that when you get in, so you have to swipe your card. So there are some certain doors which are which work on those they're electronic doors, so they work based on the access given to you, and there are some doors which kind of revolve around and then lets you in based on the your access badge. So those are all access control vestibule. Then fencing, barriers to deter unauthorized entries, having fencing, making sure that nobody enters from some other space, some other area. You can't have security around the building. I mean, you can't have that much security, so that's why fencing is very important. Video surveillance, making sure that cameras are on and they are capturing every moment around the building. So very important. Security guard, human personnel standing at the gates or around the building or even within building also. Access badge, very important. It's your ID card which is given to you, so that allows you to get into the building, into the facility, by passing through the access control vestibules, right? And then lighting ensures visibility, often deterring unauthorized activities. So lighting is important, so it's not that it's everywhere dark and you don't know who's going in and who's going out. So that's also important. Then we have sensors. So we have different type of sensors. Infrared, if you go, you see that glass doors kind of open on their own, and they get closed on their own. So they are all sensor based ones. So detect heat emission, often from humans. So infrared sensors are the persons who the sensors who detect heat emissions from humans. So they act based on that. Pressure detects rate of pressure changes such as footsteps. So footsteps, pressure changes the sensors here, right? So microwave uses microwave signals to detect movement. Ultrasonic uses sound waves to detect presence or movement. So these are all type of sensors. I'm not sure whether you're going to get any question out of this, but it is good to know information. Okay, deception and disruption technology. Okay, very important topic now. Okay, what is deception? When you are deceived, right? Simple terms, when you're deceived, it's called as deception. And disruption is when you disrupt there is some disruption around. So that's what we understand by the words deception and disruption. So let's talk, let's break it down and talk about what deception and disruption has to do here. Honeypot. So one concept that we have in CompTIA Security Plus, cyber security space, is called as honeypot. So decoy system or data set up to lure attackers. So basically this is a setup. You remember when I remember during childhood days, we used to set up this decoy kind of a stuff or system, wherein we used to catch hold of jungle birds. It's almost the same concept, like you make a fake website, probably some fake promo about something, and then you let attackers attack that. So basically when they attack, they are getting into your they're getting into your what do you say, they kind of become your prisoners in a way. So they think that they have found a surface, but that's not a surface to attack, but that's a surface to get lost into, which is deliberately created so that the attackers use that particular surface. So that's called as honeypot. What is honeynet? So honeynet is basically a network of honeypots. So if there are a lot of honeypots together, they are called as honeynet, right? Honey file, simple file. If there's a file created which talks about the company balance sheet, but then actually there is nothing, or even if there are numbers, they're all fabricated. So, or something relevant information, something important information from the threat actor's point of view. So that's called as honey file. Then honey token, a piece of data used to alert when accessed. So that's called as honey token, a piece of data used to alert when accessed. It has no real world use other than being a trap. All right, piece of data when accessed. So it gives a honey token. So it's a piece of data used to alert when accessed. So if for example I as a attacker access this, it sends an alert to the administrator, to the IT, and for me it has no use other than I have made people aware of my presence. So that's what honey token is all about. Well, honeypot might not send an alert. I mean, you might be thinking a honeypot is the same thing, that might not send an alert, but honey token does. Very important differentiation between the two. Each of these concepts plays a crucial role in broader security framework of an organization, and understanding them is essential for any security professional. Well, this was our second part. This was second video. I will be covering the the next slide and this one, explain the importance of change management process and the impact of security in my third one. Thank you so much. See you in the next lecture.